Hello, everyone. My name is Brent Eastwood. I'm an entrepreneur and founder in Washington, D.C. It's a beautiful day today. I welcome you to this talk. I'm really excited about doing this. I think this is an awesome experience, being able to talk to people without leaving my home office. So that is really cool. My startup does a little artificial intelligence and machine learning, so I've been training the machine on different aspects of that. So I'm very excited to be doing this, and right now I'm going to share my screen. So today we're going to talk about the ethics of artificial intelligence, the ethical aspects of AI machine learning. So here's some of the topics. We're going to talk about how to make sure that the machine can ultimately be controlled by human beings, and talk about the importance of having ethical, moral, and virtuous human beings train that machine. And we'll talk about how the current status of AI, machine learning, and data science can be used to conduct a Turing test. We're going to do our own little Turing test today, and that should determine that perhaps the state of the art in AI machine learning is not as advanced as we thought it was. And then we'll also take a look at robotics and the ethics of singularity. All right, so how do we maintain control over the machine? And this is really the main theme of my presentation. And I'm going to be operating under a few assumptions about AI and machine learning and the current state of the art. So let's start with the first one, that artificial intelligence is that of a 12-year-old. I believe that's most of the state of the art, especially when it comes to prediction and machine learning that we're going to talk about. And that this age of being a 12-year-old, or the level of maturity, makes it easier to train the machine. And it's somewhat easier to train in a virtuous manner, where the trainer is ultimately the hero, and the hero is the ultimate arbiter concerning the behavior of the machine. So I also believe that there are plenty of examples of much more sophisticated AI, but we believe that that can also be controlled. And let's take a look at one of the best ways, I think, to maintain control. And that is keeping it simple helps control the machine. So the first aspect of building machine learning or AI application is to adhere to some basic and simple principles. And these are in mathematical and statistical modeling. You may have heard of them. One is parsimony. We also have elegance and the necessity for maximizing the aspects of Occam's razor. Now, I don't want to get too deep into the weeds of modeling, but those principles are intuitively appealing to people experienced in tech, such as yourself. So first, in applied computer science, creating fewer and more efficient lines of code is preferable to making a hairball of code, which we want to avoid. And we can use an example of Einstein's E equals mc squared and take a look at how that was parsimonious and elegant, and that adhered to the principle of Occam's razor, because it was a short equation and just a few variables in that model. But that model explained a lot of behavior in the universe concerning mass and energy. So we want just a few variables that explain a lot of this behavior. Now, some of you in theoretical computer science remember working on search problems that you encountered in the counting problem. And this lends itself to what's called a parsimonious reduction. So that's kind of the theoretical aspect of it. And then if we go back to basic data science and say a linear regression model where you're looking for data when it's plotted to have a desirable level or goodness of fit, that means a lot of the data is grouped around the regression line very nicely. We call that the R squared, and that's the measurement that we want. It's between 0 and 1. And we're looking for something over 0.5, and that will show your model is able to explain a lot of the variability, which we prefer. All right, so let's start talking about controlling this 12-year-old machine. Remember, our assumption that we first stated about the current state of AI is that it's mostly on the level of a 12-year-old. And so in this respect, you want the machine to do only a simple chore or task, or a few simple chores or tasks, but to also have that one task have broader uses. Now, anyone use one of these simple robots in your home or apartment? The one we got didn't work very well. My wife and I tried it. But we believe that maybe if we're living in a different apartment or a different home, that this machine would actually work. And most of the tasks are pretty simple. Now, you remember the principle of a manufacturing assembly line. So if you're on a manufacturing assembly line and you're making some type of manufactured product, there's a way that you can shut down that manufacturing line if you're concerned about something like safety or quality control. So sometimes that's a good way to think about training AI and machine learning, is that the human being is the ultimate arbiter, and that person can just go ahead and shut down the line if he or she believes that the AI or machine learning is getting out of control. So think of it like that. And if you're a parent, you know that a 12-year-old, or if you remember being a 12-year-old, that sometimes you need to ground that 12-year-old and ground that behavior. And you could call that safety and quality control. So you want to be able to shut down that assembly line when it comes to training the AI too. And what we want is that the scientist is always in control. And that's the biggest fear, right? When the scientist is not in control. And those of us who work in the field have to be responsible and ethically and morally strong, and make sure you can shut off that assembly line and make human corrections at the appropriate time, especially when that 12-year-old becomes a teenager and beyond and becomes getting more mature in a sophisticated manner. Now, another way to control the machine is using simple data science. So let's take an example. All right, now, as you process this slide, it looks kind of complicated. I'm going to walk you through it, so have no fear. Take a look at the right. We have a nonlinear curve based on a binomial logistic regression. That just means that the output of this will be a probability between 0 and 1. And what probability we're looking at is the probability of a mouse click. So if we take a lot of weblog data and we start coming up with rules or variables that could predict a probability of your click, then we can also try to explain behavior or predict behavior based on various types of age, income, education, and zip code. Those are our explanatory variables. So let's pretend that we have an e-commerce website and we are selling luxury goods, and we're looking at all kinds of weblog data that's coming in fast and furious. We have velocity, we have volume, and we have variability. So we're trying to figure out what people do when they want to click on a certain luxury good on our e-commerce website. We have a lot of weblog data to examine. So we're going to look at some predictors. One thing is age. The older you are, sometimes you tend to have more wantings for luxury goods. As you get wealthier, you have the income to afford luxury goods. Sometimes this education level goes hand in hand with how much money you make and how old you are. So that's a predictor of behavior. And also zip codes. When you are looking at different people and the way they are using transactional data and making purchases, oftentimes a zip code can tell you or predict which areas of the country are more likely to buy a luxury good. Okay, so those are explanatory variables. And then what we look at is, again, Occam's razor, the parsimony, and the elegance of our model, because we have few variables, very few explanatory variables, and it's a pretty simple model. We do not have R squared on this one because it's a nonlinear relationship, but we're still trying to fit the model. And you can see on the right there where you have the multivariate analysis, and those are our variables. So we're looking at ways to figure out the probability of a click. Okay, now the machine, again, though, is a 12-year-old. So we have to train it in a way that maintains parsimony and elegance, but we also want it to predict in a very elegant fashion and a simple fashion. So take a look at that Python code down at the lower left, and some of you will recognize Python. If not, you can see the documentation. So there's only a few lines of code. So again, we're staying parsimonious and elegant. We're taking away the probability of an incidence where you have a hairball of code. So you can see that Python code is calling for a logistic regression, and the iterations are a maximum of 10. And we show with a syntax of show, and you can use that Python code to take a look and conduct all of your logistic regression needs for prediction. Now, let me give you another example of prediction. You can use these models, simple models, to also predict things like sporting events. So let's use an example of, say, a soccer game. And you're also trying to get a probability of which team is going to win. So you change your explanatory variables. And you're looking at the team and trying to predict which team, perhaps like which team has the most time of possession, or which team has the most shots on goal, or maybe which team is playing at home. So you can train the machine to find these types of incidents when you do an iteration. And you can also train the machine to recognize a certain amount of text. And that will be a predictor on how well a soccer team does. And they may have a higher probability of winning. So that's one way that we can train our machine to predict things. All right, let's move on. Now, what about when we have more complex AI? And that's really the one we have to worry about, right? That's where we need a trainer to have the correct morality or level of morality, ethics, and virtue. So this is the key to controlling a complex machine. And the ethical human is probably going to do a little bit better at training a machine that is more ethical, more virtuous, and has a higher level of a moral compass or a better moral compass. Now, here's some more complex AI, and to the right, you, I'm sure, have recognized this quote by Elon Musk. And he is scared. Now, we assume Elon Musk has seen some type of technology. Maybe it's through some of his corporations. Maybe it's through a lab he visited at Silicon Valley. He doesn't really go into real details about this, but he does talk about a lot that artificial intelligence could be a huge threat to humanity. Now, my own startup's machine learning and AI in terms of prediction, and we do prediction of world events, I kind of agree with Elon there, at least 50% of the time, that it could be scary, that it could be beyond the 12-year-old and beyond the ability of a human to control it. So I think it does get pretty scary. I don't agree with him about up to 100%, but I would say half the time, sometimes, wow, you really do have to worry about this. So I think, though, he'd agree that the trainer has to be sufficiently ethical and virtuous to maintain control in a complex machine. So let's put this theory into reality. Is it really that scary? Now, here's a good example of a robot that is in Korea on the demilitarized zone between South Korea and North Korea. And you can see that there's a weapon at the top on the left there. That's, we assume, is a machine gun. It's got various cameras. And this particular system is controlled by the Republic of Korea military forces, not the United States forces. It is controlled by South Korean military personnel. And it is not an autonomous robot, but it is a system that we assume the man has control over the machine. Now, if you look at when this article was published, this system got deployed. It was probably tested in 08, 09, and they had deployed it later in the year, probably in 2010. Now you see where that's highlighted. So we assume this system has been going on for the last 6 years, and I don't know of any other time that it went offline or malfunctioned, but you could imagine that if it went wrong, according to Elon Musk and others who are scared of artificial intelligence, it could start a war at the DMZ. So we have a lot of trust in this system. I don't know of any time that it has malfunctioned and started shooting indiscriminately, but it would be scary if it did, the machine did take control over the system and it malfunctioned. And so that risk is always there. But in this particular instance, probably man still controls the machine. All right, let me move this. So, there, that's better. You can see that. All right, so what if we did our own Turing test? What if we took this presentation and showed you a simple data science example that may surprise you? And you see that quote right there. And that's a description of the Turing test on whether a machine can think. Is it indistinguishable from that of a human brain? Great book by Walter Isaacson where this quote is from, called The Innovators. And many ways to take a look at the advent of computing, software, hardware. There's a little bit of AI and machine learning in there, but it's a great book. And we can take a look at this as social scientists or computer scientists and find out about doing a test on whether a machine can think. We're going to do our own tests. All right, so here's our imitation game that I'm going to show you. And this is kind of a humorous slide, obviously. It doesn't fit in with the rest, but it hopefully is getting your attention. All right, so we're going to have our imitation game. And we're going to compare a NoSQL data architecture on the left to a SQL data architecture for our own Turing test. So let's take a look at the left. If you all are into data science and big data, you know that Spark is at the cutting edge, and for database, MongoDB is pretty awesome, and Apache has got some other tools, Kafka, Cassandra. If you don't know much about Elasticsearch, it is really cool, and so I recommend that you take a look at that. And this architecture, we've got the 4 V's or 3 V's of big data: volume, velocity, variability, and some people call veracity the last V. All right, so that's our data monster, and most people like to do data architectures in this manner so it can handle structured and unstructured data and big data coming in at high velocities. Now let's go to the right, and this is our MySQL kitty cat. Wow, isn't he cute and cuddly? These are for relational and structured database, and we can use MySQL or different types of SQL. In Spark too, Spark can handle regular SQL. So you see that we have a data monster compared to our little kitty cat. So let's execute our little Turing test. So we're going to have 3 individual and separate rooms. We'll have one room where the NoSQL monster is sitting. We'll have our second room where the SQL kitty cat is sitting. And then we have our third room where a human being is sitting. And the tester is going to ask a question. And here's the question. Do you ignore some types of data? All right. Do you ignore some types of data? The SQL kitty cat says yes, because the model has different rules about which type of structured data that the MySQL kitty cat is going to examine. Now the human will be asked, do you ignore some types of data? Well, yes, human beings do ignore some types of data. Then we ask the question to the NoSQL monster. And since it does not ignore any data, it's got a big pipe and it's capturing all kinds of data, it says, no, I do not ignore certain types of data. I don't ignore any data. So which one is the intelligent one? Kind of ironic there. Probably not what we expected. And, on Turing tests, you're going to spend much more time and many more questions. But that is the state of the art. All right. So we're not sure which one is really intelligent. Or maybe we are sure. But it's not really what we expected. And this is just a little ironic exercise. And you can take a look at different examples like that. But I thought this would be a good way to show how our expectations about AI and machine learning are not always what we think they are. Now, here's a good example. So we are getting more complex in our AI and machine learning now with IBM Watson, but we still need to control that complex machine. What if we, instead of making a robot or machine kind of mean, what if we made the robot or machine more collegial, that has a polite voice and a good bedside manner, that is not threatening, and it wants to collaborate. Well, that's the idea behind IBM Watson Health. Watson Health came about because IBM thought, hey, if we scan in a bunch of medical records, if we scan in all kinds of medical data, and also take medical journal articles and we put them all in the machine, and the machine does some deep learning, we assume, and out comes, the output would be a real doctor that could work with a human doctor and say nice things. Like, instead of saying, you must do this, I am correct always, the IBM Watson Health machine says there's a 40% probability that you will like this recommendation. Oh, how nice and polite. So take a look at what I say and check for yourself. But I think I have a 40% probability that I feel sure that this diagnosis is correct. So Watson Health is a computer hybrid model that Peter Thiel talks about that is desirable. This is augmented intelligence instead of straight artificial intelligence. So we're making the machine more likable and collegial. It seems non-threatening. It seems like a friend. It seems like a doctor with good bedside manner, which is all the great things you want when you're diagnosing a human being. Aha, all right. Here we go. There's Matthew McConaughey in a movie called Interstellar. And if you haven't seen this movie, it has different aspects of robotics. And his main friend during the movie is a robot called TARS. There's also another robot called Case, but TARS pretty much steals the show. Now, TARS can be very collegial. He can be a team player. He can be nice, and he's usually polite. But he also has a kind of a sarcastic side to him because he has a humor setting. And he, in the movie, makes a couple of comments that are a little unsettling. And let me see if I can show you a clip of the interaction between Matthew McConaughey and TARS. Now, let's back up a little bit. Could you imagine Matthew McConaughey as like your computer science professor, artificial intelligence, like, all right, we're going to do some artificial intelligence teachology right now. Could you imagine him as a professor? I would love to see that. All right, let me see if I can make this video happen. All right, let's minimize this and let's go to our clip. I'm going to turn up the noise here so you can hear it. Hope you can hear that.
Everybody good? Plenty of slaves for my robot colony. We handle the humor settings. We fit in better with his unit. Thinks it relaxes us.
A giant, sarcastic robot. A great idea.
I have a keylock I can use when I'm joking, if you like.
That'd probably help.
Yeah, you can use it to find your way back to the ship after I blow you out the airlock.
What's your humor setting, Todd?
That's 100%.
Let's bring it on down to 75, please.
Stage 2, separation.
All right, let's go back to the slide. I love that scene. All right, so let's start again. And so that's the interaction between Matthew McConaughey and TARS. Hey, TARS, bring that humor setting down to 75. Take it easy. We're a little scared about your sarcasm there, right? Okay, so that is when TARS is a bad boy. And look at those quotes again. Let's go over them. This is what he said in that clip. I have plenty of slaves for my robot colony, meaning human beings, okay? It's a humorous comment, but kind of scary. How about this one? You can use it to make your way back to the ship when I blow you out of the airlock. Are you kidding, TARS? I mean, think about that quote, And so Matthew McConaughey and the crew are sitting there and they're not that amused. So think about that a little bit. Think about that in terms of the way we control artificial intelligence and train the machine. Yeah, we want to let it have human characteristics like humor. But if the setting is too high, in this case 100, that TARS makes inappropriate comments and kind of scary comments. So the human intelligence is able to control that machine and take the humor setting down to 75. And hopefully TARS turns into more of a good boy. Aha. So the question is, if TARS is a good boy, and if our intelligence, our artificial intelligence has a collegial quality that's polite and collaborative and nice and has a great bedside manner, does that machine become ethical? And I think that is a critical question, because we assume all of our little robot friends will be controlled by us, and they're going to be nice. They're going to be a nice R2-D2 type of robot, or a nice TARS. In this case, there's a scene where he's saving one of the astronauts to get back to the ship. So TARS can be a good boy. And what we have to ask ourselves is, if we make robotics collegial and make it seem like it's able to work with humans in a benefactory role, is that the same as making it ethical? So let's go back, and I'm going to show you one more clip. So let me minimize this. I'm going to go back to this clip. All right, now this is not to be a spoiler alert. I won't say anything on when this particular scene happened.
General settings. Security settings.
Honesty, new setting, 95%.
Confirmed. Additional customization.
Humor, 75%.
Confirmed. Auto self-destruct T-10.
All right. He still had a joke there at the end. But you see that our hero is controlling the machine. And TARS is still collegial. We believe that this is a more of ethical virtual model, because we assume that Matthew McConaughey's character is the one that is virtuous. He is heroic. He is ethical, and he is in control. What happens when we try to make the robot buddy a little more collegial and nicer, and in a manner that is non-threatening and collaborative? In this case, we have a good collaboration here. TARS is saving a human being. If we do all those things, is this the same as creating ethical artificial intelligence? Does collegial mean ethical? So that's the question that we need to think about. Does it still mean we can control the machine, even if it is collegial? Let me move this. So here we are. We have a thinker about artificial intelligence. This came out on National Public Radio. It was a commentary, a column on the ethics of the Singularity event. And if you remember, the Singularity event is when computers are smarter and they can even program themselves to be super smarter. So this particular writer is very skeptical of that singularity notion or concept. And if you look down at the right where it's highlighted, you can see that she believes that it's our intelligence, our agency, and our interests that are underlying all artificial intelligence. So as a skeptic, she's worried too that we will lose that control over the machine. And it's all about maintaining control. So can we create this ethical machine or ethical robot? And one way is to be skeptical of this singularity and make sure that it's our intelligence, our agency, and our interests and our concern for solutions that are on display. So here we go back into the conclusion of our talk. So one of the first ways to maintain control over what I call a 12-year-old level of maturity in artificial intelligence and machine learning, and I think most of the AI and machine learning, especially in terms of prediction, could be considered at the 12-year-old level. Then we have more complex over on that side, meaning that the maturity level in terms of technology for some AI and some machine learning is much higher than the 12-year-old, but it's easier to train that 12-year-old as long as you know that you can sometimes stop the assembly line. You can stop it when you see something that you don't like. You can change TAR's humor settings. You can change that sarcasm and train that 12-year-old and say, no, you know, that type of talk is inappropriate. I'm going to take your humor level settings down. I'm going to take your honesty at a different level too. So again, we maintain control over that machine by either acting like it's a 12-year-old, or if in a more complex way to look at it, is that we shut down the assembly line when we believe that there's a danger and that the trainer is the human hero. So the human hero makes the last call, and the human hero is able to change settings, stop the assembly line, and train an ethical and moral and virtuous machine. So, is artificial intelligence our biggest existential threat? I would take out that word biggest. I think it is a threat. It may not be existential, although it could be. So I agree with Elon Musk about 50% of the time. I see my own artificial intelligence and machine learning in my startup, and sometimes it's a little bit scary in how good it is, or sometimes not. Sometimes it doesn't work very well, and you have to train that 12-year-old. So we maintain control in an ethical and virtuous manner to mitigate the threat of existential machine learning and artificial intelligence. So I want to thank you very much. I apologize for killing part of this talk, but hopefully I picked it up where you guys left off. I think so. Again, I thank you. This is my contact information. That's my Twitter handle. You can check out my website. I'm in Washington, D.C. I also teach at George Washington University, Elliott School of International Affairs. I am a lecturer there, and I do get into a little bit of AI and machine learning in terms of trends and international security. So I thank you very much, and I am going to try to get out of this, go back to the dashboard without killing something. Okay, let's see. We are back up. Even without the slides, it was still fun. Okay. See if there's, okay, I don't see any other questions. All right, I don't see any questions right now. So let's go ahead and stop recording, and thank you very much.